All right, let's talk about an element named after Thor, the Norse god of thunder. And honestly, the name fits perfectly because just like its namesake, this element, thorium, holds both this incredible promise and a really serious hidden peril.
And that's really the heart of it, isn't it? Is thorium this amazing key to a green, clean future? Or is it a dangerous radioactive legacy that we'd be much better off just leaving in the ground? As you're about to see, the answer is, well, it's not simple at all.
Thorium has had such a roller coaster of a history. It was discovered way, way back in 1828, but for decades, nobody knew its secret. Then, in 1898, none other than Marie Curie helped figure out it was radioactive. It became this wonder material, especially in aerospace. But then, people started realizing the health risks, and its use just plummeted. But now, it's making a huge comeback, and it's being driven by the biggest technological shifts of our time.
Okay, so let's start with the good stuff. The promise. Why is everyone suddenly talking about thorium again? Well, it all comes down to its potential as a nuclear fuel, and one that could be fundamentally, and I mean fundamentally different from the uranium we use today. So just look at this side by side with uranium. On paper, thorium looks like an absolute slam dunk. First off, there's way more of it in the Earth's crust, so it's a much more secure energy source. Second, and this is a big one, it's incredibly hard to turn into a weapon, which gets rid of a huge geopolitical headache. And maybe most importantly, the radioactive waste it creates is so much less of a problem long term. It just doesn't produce nearly as much of that really nasty, forever toxic stuff like plutonium.
But here's where the story gets even more interesting and kind of tangled. It turns out our modern green economy is already deeply connected to thorium, whether we realize it or not. You see, all those powerful magnets inside electric vehicles and wind turbines, they need what are called rare earth elements. And guess what you find right alongside those elements in the ground? Yep, thorium. So the bottom line is, if we want to build a green future, we already have to figure out how to manage this radioactive byproduct. There's no getting around it.
And that brings us perfectly to the other side of this whole paradox, the peril. For all of its amazing potential, thorium is radioactive. And the specific kind of radiation it emits poses this unique and very serious threat, but only if it gets inside your body.
So let's be really clear about what the danger is. Thorium is what's called an alpha emitter. Now, on the outside of your body, alpha particles are so weak they can't even get through your skin. They're harmless. But, and this is a huge but, if you breathe in or swallow thorium dust, it's a whole different story. Inside you, those same particles act like tiny microscopic cannonballs, just shredding your DNA and causing massive damage in a very small area.
And look, this isn't some theoretical what-if scenario. We have a tragic real-world case study of exactly what happens when thorium gets inside the human body. For decades, there was this medical product used all over the world called Thorotrast.
So what was Thorotrast? It was a liquid that was 25% pure thorium dioxide, and doctors would inject it directly into a patient's veins to make their blood vessels show up better on X-rays. Just think about that for a second. They were putting a radioactive material straight into people's blood.
And here's the absolutely devastating part. The human body has no way of getting rid of thorium dioxide, no way to flush it out. So it just stayed there. It would build up in the liver, the spleen, the bone marrow, and just sit there, blasting the surrounding cells with alpha radiation for the rest of that person's life.
The long-term studies on these Thorotrast patients gave us undeniable tragic proof of the danger. This continuous internal radiation led to an absolute epidemic of rare and aggressive cancers. The final verdict, based on all this evidence, was crystal clear. Thorium is officially classified as a known human carcinogen. So, okay, we've got this incredible nuclear promise on one side and this terrifying biological peril on the other. But there's another layer to thorium that's just as fascinating. Beyond all the radioactivity, it's just a physically weird element. I mean, it's a material of truly mind-bending extremes that make it totally unique. Okay, get this. Thorium has the largest temperature range in its liquid state of any element known to exist. It melts at around 1750 degrees Celsius, which is pretty hot, but it doesn't actually boil until almost 4800 degrees. That's a liquid range of over 3,000 degrees. That level of thermal stability is just, it's wild. And here's a few of its other party tricks. It's incredibly dense, denser than lead.
But just look at that last number. The half-life of its main isotope, Thorium-232, is 14.05 billion years. That's not just older than the Earth, that's about the same age as the entire universe. It's literally been around since the beginning of everything.
And the weird science doesn't stop there. There's this one particular version of thorium, an isotope called Thorium-229, that has this really unique feature that has physicists totally buzzing. It might just be the key to building something straight out of science fiction, a nuclear clock. So here's the simple version of how it works. The core, the nucleus of Thorium-229 has this special low-energy state that, amazingly, we can poke with a laser. It means we can basically talk directly to the nucleus using light, which is incredible. So the idea is, if you can lock a laser onto that super stable frequency, you could create a clock that is thousands of times more accurate than even our best atomic clocks today. We're talking a revolution for everything from your phone's GPS to how we search for dark matter.
Which, of course, brings us right back to where we started. On one hand, you've got the promise of a superfuel and a revolutionary nuclear clock. And on the other, the peril of a lifelong internal poison. So, what do we do? How do we move forward with this? This really is our modern dilemma, isn't it? Thorium offers a real path to cleaner nuclear energy. It's already tied inseparably to our green technology supply chain. But the health risks from breathing it in are severe and they are proven. Thorium isn't a simple hero or a simple villain. It's this incredibly powerful tool. And the price of admission for using it is figuring out how to manage its immense risk perfectly. And that's the question we're left with. This element, named for the god of thunder, offers us a chance to harness truly immense power. Power for our energy grid, power for our technology, power for our future. The only real question left is, are we wise enough to wield it?